Welcome to the fourth lecture of our digital forensics course. In the previous lecture, we have mentioned file system fundamentals. Now we will try to explain advanced file systems and then we will move on to evidence acquisition. What we will cover in this lecture is the metadata, details of a directory table, not specific to any file system, but a generic idea of how it is located, how it is constructed. We will mention some tools that you can use in a Linux system. For example, in Kali Linux system, which is a very common operating system, Leo operating systems, that you can boot without touching any evidence in a read-only mode and use. This Linux operating system includes these tools. Then we will go on about reconstructing the information on a disk storage. We will explain what happens when you delete a file, and we will explain what happens when you format a drive, and we will try to revert these changes back and try to locate deleted files and try to read the contents. And we will also try to show you the idea of reconstructing entire file systems. Finally, we will mention some automated tools that can do these for you. These are either proprietary or open source tools that you can use. Let's start with the metadata. Metadata is, the wording means the data about data itself. So actually when you mean metadata, actually it is data on a set of other relevant data. In this context, what we are using metadata for? When you try to store a file in your hard drive, you are not only storing the data, but you also store some metadata that is relevant to it. The most basic one, as you can guess it is the directory table. Because if you want to locate that file, after some time, you need to find its place on the hard disk drive. You don't go and search for everything. And to know its location, you generate an entry in the directory table of the file system. And this is the most basic metadata we are using. The existence of one directory table is crucial for any kind of file system. And these tables, most of the time, include other data that could be useful for the computer users. For example, the date of the creation of the file, the date of the modification of the file, the date, the time of the last access, also the owner of the file or who last accessed that file, some permissions, either it is readable or not, if someone could access it or not. There may be some other relevant data if the file is, let's say, compressed or encrypted, and the file system itself may feature such properties that you can use. And this is what we call metadata in the file systems context. And you can easily say that the directory table is mostly composed of metadata. I would like to make a note here, because this could be important and this could be confusing. In the previous lecture, we mentioned file headers. File headers are actually, again, some metadata about the contents of the file, but they reside within the file because they explain only the file. The metadata, in this sense, is the data that is kept out of the file. So you have kept metadata, and this is managed by the operating systems. And if something is managed by the file itself, it resides in the header part of the file. So after this distinction, let's go on with the directory table. As we said, the main idea of a directory table is you try to find the exact location of the stored data in your hard drive, and to do that, you just divide your hard disk space, the physical space, into smaller blocks, and you address each block. So you have, let's say, 100 blocks numbered from 1 to 100, and you say this file named image.bitmap resides in block number 55. So you just go to 55th block with your hard disk drive. It is done automatically for you by the hardware, and start reading that part, and you see first the header of the file and the contents of the file, and you can visualize it on your screen, for example. In this directory table, as we said, you also keep metadata. The size of this table could be limited or unlimited, and these kind of details are changed depending on the file system you are using. And maybe it is better to say what happens when you format a brand new drive. When you format a brand new drive, most of the time, what you do is you just generate an empty directory table. This directory table says, okay, I have that number of blocks, I have nothing in this block, and the block's start addresses are these addresses. So now your drive is usable. When you make your drive usable after that point, if you create one new file, the hard disk or the software of your hard disk, let's say the operating system, put this file in the first empty location, generate an entry, generate a line in the directory table, and you start using it. If you add more files one after another, after a while, first your directory table gets very crowded, and second, this may not be a problem for your computer, but second thing is more important, it will not be very usable, because you will see all files in the same structure one after another, and you cannot kind of organize this structure. That's why you use hierarchical file systems. The first files, the first directory table includes some structure about the disk drive itself, and then includes some references. And one of these references could be another directory table that lies beneath the root directory. And if you have one more directory table behind that, you can actually easily build a hierarchical file system. And this is what we use today in our computer systems most of the time, with the rare occasions that sometimes very small file systems like SIM card file systems could be very flat file systems. Otherwise, nearly all operating systems use hierarchical file systems. So what exists in the directory table is easy now. we have the metadata, we have links to related blocks. If there is some kind of file that cannot fit in one block, you have either the ordered list of blocks, or you either have the first block's address, and these blocks could somewhat find the following block for you. These are different designs and file systems. And finally, directory tables could include other directory tables. Now let's think about the root directory table. It is kind of spatial. What makes it spatial is it actually includes the physical structure of the drive. So it has some additional entries that defines the physical properties of your drive, the size, and maybe other relevant data that may be useful for your computer to use that device. And within that one, directory table, you have all these data and also one serial number. This serial number is unique. It is generated every time you format the drive. And otherwise, you never ever delete this directory entry, your root directory entry, but you may only manipulate it. If you want to see this data in a Linux system, you can safely use File System Statistics, FSStat tool. This will show you many details about the physical structure of your drive, and also it gives you one hint that could be useful. For example, if you have a copy of the drive at some point and another copy of the drive at another point, but in the second drive copy, in the second drive image, you see that this serial ID is changed, then you can easily say that this drive has been formatted after we take the first copy. Another useful tool about file systems could be the file. The file tool, its name is also file. The file tool is very useful because it checks the exact data, exact header of a file. So if you don't have any kind of information about the file extension, you don't know if it is a sound file or if it is an image file or if it is an executable, you can just use file command, and the file command will extract the header information. And if the file has some kind of structure, some kind of known structure, standard structure, it will be shown on the screen. So you can reason easily about the file. And think about these headers. When you have a file header, most of the time you start with some kind of specific signature to distinguish this file type from another file type. And the signature is repeated if you have many files and then maybe some other details. For example, as I said before, every bitmap starts with a capital B and capital M letters, and then it includes the color depth, the resolution, or some width and height data, and then the actual contents of the image started. If you don't know what exists in a hard drive, you don't have any file system, but if you could manage to search all hard disk without even considering the file system, even if you don't know the file system at all, and if you encounter one capital B followed by one capital M, you may think that, okay, this could be a bitmap file. Then you can check the rest of the header if the standard format is protected there, if it's resized like that. If you see a color depth information, if you see a width and let's say a height, and then you can try to format all the image that follows the rest of that's following in the rest of the hard drive. So you can try to find this. Actually, what happens when you delete a file is something like that. Always think that computers are built to perform. So when you delete a file, you don't actually go on to the hard drive and fill the area with all zeros. But actually, there is a very simple solution. The files you can follow are included in the directory. If you delete the line that is relevant to this file in the directory table, actually the file will not be visible to the operating system anymore. So just to perform, operating systems do these. They don't actually go and delete any file. They just delete the line in the directory table. So if you have the directory table, actually deleting a line from the directory table is something like that, because your directory table is mostly include the number of files as the accepted, as the files that reside within that directory. So in the beginning of this directory table, you say, okay, I have 5 files in this directory, so just consider the first 5 lines. And if you just move one of the files, after that, it cannot be recognizable. Or if you want to delete the last file in this directory that has 5 files, you don't need to even delete that line. You just go and say that I have 4 lines instead of 5. Then the 5th line will not be recognized. As a result, you can find the traces of file itself in the directory table. And even if you cannot find it, you can go and check the empty spaces in the hard disk drive and search for file headers. In any case, it is very probable that you can find a recently deleted file, because no other file will be overwritten yet. There is always a chance that this file is partly or completely be overwritten. It's by chance, but it is possible if you are quick enough. If you just try to find a recently deleted file, you can undelete it. And let's think about constructing entire file systems. For example, you format the whole drive. After you use it, you just reformat it. Previously, you had a structure of files, MP3s, images, and so on in this hard drive, but you formatted it, so you cannot access any of it. You cannot recognize any of the entries. What you do by formatting this, for formatting a file drive, is something like you are just overwriting the root directory table. So the rest of the directory tables are still in the hard disk, because your computer will not spend its valuable time to go and delete all these magnetic fields and so on. It will just update the relevant part. It is the master, the root directory table. So if you search through all hard disk once again and try to find the directory tables, imagine that files has headers, so you can find file headers in the empty spaces. Now you have the empty space, the whole disk is empty, but you are searching for directory entries. Luckily, we have some kind of structure for directories, directory tables. So it will act as a file header, and we will search for directory table entries. And whenever we encounter with a directory table entry, something like I have 5 files and the addresses are that and some metadata, I can just keep those copies and then try to find if addresses match. For example, if one directory points block number 5 and the block number 5 includes another directory, I can actually understand they are related, and I can place one of the directory under another directory. So I can actually try to build the whole file system with including the files. This is maybe not always possible. It is again probabilistic because you don't know what parts are deleted and what parts are not. But if you format a drive very recently and you didn't do anything with this file system again afterwards, it is very probably that you left the remainings intact, and you can try to build nearly 100% of the file system from these remaining data. These could be very difficult, and you may need to learn the details of each file system, each directory structure, each file header, and luckily we have some dedicated software for that. Encase is a proprietary software. It is very famous. Autopsy is the best for today's forensics tools, and it is open source. WinHacks is also a commercial product. These programs know the structures of directory tables for different file systems, and they know the header types and structures for many standard file types. So you can just use them, and this may actually ease your process of data system examinations, and you can benefit from these automated tools. These three are just to name the few and maybe the most known ones, but there are hundreds, maybe thousands of others that you can use. So this is all for this lecture. See you in the next one.